Hello everyone and welcome to this section that we call CEA Spotlight, where we speak about different articles linked to controlled environment agriculture. So today we're going to be learning about the use of supplemental lighting in a strawberry inside of greenhouses. So today we're going to have a quick summary about an article that is called Supplemental LED Lighting Effects on Growth, Fruit Quality, and Yield in two different greenhouses for two different strawberry cultivars. We're going to be speaking about very popular cultivars, Albion and San Andreas. So this research was done by the University of Colorado by Andreas Stemke and Mark Osansky. And the objective of this research is to evaluate the use of supplemental lighting with three different treatments and a control to see the effect of different spectrums of light that are added into the greenhouse when we have a DLI that is not enough. Inside of the greenhouse, we usually use supplemental lighting. So in this article, they are evaluating the different kind of lighting sources that we can use in order to improve the DLI. So for this research, they did two different experiments. One was done when the DLI was going down from October to December, and another one was done when the DLI is increasing from January to April. First of all, let's start explaining the treatments that they used. They had a control, first of all, which was a greenhouse with natural light and also supplemental lighting with flowering lamps. These flowering lamps include red, white, and far red. And for the treatments, they add a little bit of blue. The first treatment was called a WFR, which is in here. And this one included the use of flowering lamps and also medium blue. Then they had the treatment called LB. In this one, they use flowering lamps, deep and red blue with low blue in this case. And then they had another treatment that was called HB. This one includes deep red blue and high blue and the flowering lamps. Speaking about the light intensity that was used for this experiment, the light intensity that the crop was receiving was around 90 micromoles per square meter per second. So that was the intensity that was used, including supplemental lighting and natural light. And the total DLI was from 7 to 10. This is actually, just to let you know, this is actually a very low DLI. Usually for strawberry, we target a DLI between 12 or 17. For greenhouse production, even 20 sometimes. So in this case, they use low light intensity and a low DLI. So I just wanted to let you know this because, of course, on the results for yield, we are going to see, of course, a strong response to the light intensity that was used in the experiment. Here we have the results. These results are from the first section of the experiment when the DLI was going down from October to December. And you can see two cultivars, Albion and San Andreas. They have a kind of different response. San Andreas is having a stronger response to the treatments. We can see a significant difference from the control for both cultivars, meaning that the use of supplemental lighting is increasing leaf area. And you can see also the difference between the treatments. When we have, for example, when we have more blue, when we have less blue, there is a difference on a leaf area and also with the treatments with far red. From this, we can conclude that the use of supplemental lighting and specific wavelengths can help you to increase leaf area. For example, for far red, we know far red is helping to the plant to make the shading avoidance response, which can help the plant to capture more light and be able to do more photosynthesis, which can also be translated to a bigger leaf area. Now, if we evaluate the yield that was obtained in this experiment, in these results, they are mixing, this is an average from the first section and the second section of the experiment. And again, we can see difference between the control and the treatments. And we can see also a difference between the treatments for both Albion and San Andreas. What we are looking here is that use of blue light can have a good impact on yield in this case in comparison to the rest of the treatments. So the main takeaway from this experiment is to learn that the use of supplemental lighting can help us in comparison to a control to increase leaf area and yield on our plants. And after that, there are different spectrums that we can select, and there are specific colors that can help you to provide specific benefits, like, for example, increase in yield or increase in leaf area. Two colors that are important in here: high blue and far red. And of course, red is one of the most important colors for photosynthesis. Every light for plants will have red. In this case, for strawberry, we know a spectrum that is including red, far red, and blue and white can be a good option when using supplemental lighting inside of greenhouses. And well, that's all the information for today. I hope you enjoyed the information. Let me know if you have any comments or questions. I will leave the description, all the information of the article at the description section, so you can check the full article and read all the details. Remember that in this case, they are using low light, low DLI as treatment for all the situations on this experiment. So just take in consideration that. And let me know, like, any kind of topic that could be interesting to you, so we can continue learning about the research done by academia, so growers can learn how to apply the information directly on their systems. Remember, my name is Karla Garcia, Hort Americas Technical Service. See you on the next video.